Hello Year 9s, this is the second booklet on electricity and magnetism. First thing that we're going to look at is symbols. Draw a symbol into the box that represents something in the world around us. Well, here's a symbol. I wonder if you can guess what that means. It is, of course, the Nike symbol. Could have had the golden arches, McDonald's. Why do humans use symbols to represent objects or actions? Well, number one, it's easy to understand. It can take quite a complicated object or a set of actions and boil it down into a simple symbol. Plus, of course, symbols can be understood whatever language that you speak. So they can be very, very powerful. Now, try to name the symbols below. You're going to make mistakes. Don't worry about it. Even if you want to go on the web and try and find these, that's fair enough. The answers are going to come up in a moment, but pause and research and then come back in a moment. So the first three. Left, church with a tower. The centre one, pure wool. And the female and male, with a line in between, that's public toilets. And the final three, AU, symbol for gold, EB, Bugatti, and the symbol with a circle with a little cross by it is a female. So symbols can represent objects. Now, in front of us we have a circuit. I can see two batteries. I'm going to go with another colour actually. I can see two batteries there. I can see wires. I can see a couple of bulbs. And I can see some more wire there. I'm just going to remove all that highlighted bit. I'm going to draw that using circuit symbols now. Now you may or may not know what the symbols are. Now I can see here that this is the positive end of the battery and that's the negative end of the battery. So that's the positive end there. This is the negative end. That's one battery, but I'm going to include another battery because there's two of them. Now, you can see these wires here are all wavy. You should really be using a ruler to help you out here. Ruler. The computer doesn't seem to like my ruler, but I'll keep on going for a little bit longer. No, it doesn't like it. So I'm going to have to draw freehand, unfortunately. But you should be using a ruler, and we're going to come across a bulb. A bulb is a circle with a full cross through it. But there's another bulb a little bit further down. I'd be using a 2p piece or a 5p or a 10p to draw around the bulbs. Then we've got some wires coming through, and like so. And then we've got that brown wire linking up with the left-hand battery. Like so. Now, you use the internet to find the symbols for the following electrical components. 1, 2, 3, 4, 5, 6. This is what they're going to look like. I'm going to let you know now. I'm going to give you some verbals, and I want you to write down some of what I say. I'll let you know. This is a cell. It's got a positive and negative side to it. It's called a cell. This here is an ammeter. It measures the flow of current in amps. The flow of current is the flow of electrons. This is an open switch. The switch is off. This one here is a closed switch. The circuit will be complete. The circuit will be on. We know that this is a bulb. And this one here is a voltmeter. What does it measure? It measures voltage or potential difference, or PD. They're all the same thing. Voltage, potential difference, PD, it's the same thing. It's measured in volts or capital V. They're the first 6. Moving on, we've got 1, 2, 3, 4, 5, 6, 7. Okay. A resistor. It resists the flow of current. This one here is a variable resistor. We can change its resistance, so we can change the amount of current flowing through it. These are seen in dimmer lamps or volume controls, because you can increase or decrease the volume. This here is a fuse. It's a very thin wire, and if too much current flows through it, it melts, preventing fires. Now this here is a battery, a collection of cells. In actual fact, I can see not 1, not 2, but 3 cells there. So if each cell was 4 volts, this battery would be 3 cells multiplied by 4 volts each, gives me a battery that is 12 volts. This is an LDR, a light dependent resistor. They measure light levels, and the resistance and current changes as a result. You see those on top of street lamps, and it causes the street lamps to turn on and off depending on the light intensity. This here is called a thermistor. Its resistance changes with temperature. They're used in digital thermometers and central heating units. Now this one here is a diode. Only allows current to flow in one direction. In this example here, current flows to the left. Okay? Now, revise these symbols. Be able to draw them out. Remember that voltage is called potential difference, or PD. Know your symbols. That will be the end of lesson 1.